Hi guys, welcome to our discussion. Today we are going to look at one of the sections that we had said in our last video. I promised that today we are going to tackle a topic on rational exponents, and this follows some of our videos that we have already discussed on representing what we refer to as exponential notation, whereby we looked at one of the, of course, sections on this, which we had given on integral notation, and then we said that we were to discuss on topic for today, which is of course representing what we call rational exponents. So in this case, I hope that from this particular case, we had given specific examples, and we said that from the first one, we can be able to give an exponential notation. I'm basically going to give a summary of this so that it can assist us to understand our discussion for today. We had given a general representation for this being this particular equation, which represents a number that is a product of factors of a base a raised to the power b, and that is applies for two conditions whereby if b is an integer, which is basically a negative, a positive or a negative one. For the positive one, we say that if b is positive, then we're going to have n represented as the product of a, which has been factored b times, or which has been multiplied by b factors. And then next we say that if it's a negative, if b is a negative number or integer, then we are going to have this one represented as n as a product of let me just put it right. So this is n as a product of base a raised to power negative b, then which we said that of course this negative integral exponent represents a multiplicative inverse, whereby we say that then n is going to be represented as an inverse, which is a which has been multiplied by b factors. And therefore, lastly, we said that of course for what we call a zero exponent, this basically gives a unity which is 1. So therefore, this is a summary of what we have discussed in our last two videos, which are going to give us a basis of finding out how we can be able to represent rational exponents. So I'm going to do away with this so that we can have this quick discussion on the rational exponents. So basically, if I try to give an arbitrary example for the normal, just an arbitrary example of numbers or an equation like this. So this is 2 raised to 2, which is going to give us a product of 4. Now suppose we have a general expression for a number a raised to power n, which is going to give us b. Then therefore from these two expressions we can be able to have a representation for these two specific numbers. Now for the case of the second one, this will have an implication of what we're going to give us a can be represented as b, which has been raised to that particular 1 over n. And then if we try to give an analogous expression for this specific first part for 2 raised to power 4, this is a general example. This is a general example why this one is specific. We're trying to see how we can be able to represent this. So this is going to be given as 2 is equivalent to 4 raised to a half. So if you try to look at the relationship between the two, we're trying to figure out how we can be able to generate what we call a representation for giving an inverse, or rather for giving an inverse of this particular power on this other side. So this refers to operations of raising a number base to a power. For instance, the examples I've given above are going to assist us on how we can be able to write this. Now suppose I write this second representation still and give it another form, then I'm going to have a represented as a or rather A represented as n, and then B. From indices, we're going to see that this is one of the applicable laws. So if we try to represent this one as such, then therefore we're going to see that if the numbers that we're using for A, B, and C are integers, therefore we can make a conclusion and say that A to the power B over C, which is going to represent what we call, I hope that we know the concept of rational numbers from the previous discussion of a video on different types of numbers, whole numbers, rational numbers, irrational numbers, etc. So this is going to give us A raised to B over C, which of course the power is going to be a fraction. So therefore this one can as well be represented using this specific form that I've given on this other side by giving it as a C. Then this is going to be A, B. So this can be given as this. So in giving this specific representation, I'm going to just use these two examples in order to discuss basically what this one entails. So therefore, we're going to represent to refer to the first part of this specific expression that I've given here, that is ABC. So this first part is going to be referred to as exponential notation. This is going to be an exponential notation now that we have talked about the concept of notation. And then the second part, which is this one, is going to be referred to as the radical notation. So the first part of this, as we can see, it's A raised to this particular rational number. Then therefore we can be able to refer to that one as a rational exponent. So this exponential notation for this one is representing a rational exponent. So this basically from our discussion is what we're going to achieve by trying to represent this particular annotation in this particular format, which basically is going to be referred to as rational exponent. We're going to see a range of numbers which are going to be represented as such. And when we're going to discuss about the laws and the rules of logarithm and integer indices, then we're going to see how specific operations are going to be used in order to treat that. So I hope that one is so understandable. So catch us in our next video so that we're going to discuss about the concept of laws of indices and logarithms. So that is it for now, guys. Bye. God bless you.